Hello dear friends, welcome to my YouTube channel Cheat Academy. In the previous video we have seen what is logarithm and we have seen the conditions when it is defined. Okay, so in this particular video we'll be talking about the properties of logarithms. So let us start. So to begin with, let's conclude what we have done in so far sessions. So we know that log is defined for positive numbers, and when I say log of n to the base a, that's x. Okay, so this is defined when n is greater than 0, a is greater than 0, and it is not equal to 1. And this x, this could be positive or negative, right? So how do I write this in terms of exponential form? So the same thing could be written in exponential form as n is equal to a to the power x. Okay, so these two notations are one and the same thing, but this is how we write log. Okay, invented by John Napier. And then we had seen few standard results which were, log of 1 to any base. These were standard results, which was equal to 0. And then we had seen if this number x and this number, b, if product of x and b, right, multiplied together, if this thing is equal to 1, that means they're reciprocal of each other, and this answer will be equal to -1. Okay, so if b multiplied by x is equal to 1, then the result is -1. They are reciprocal of each other, x and b. So I could write here, they are reciprocal of each other. This is what we have seen, reciprocal of each other. Okay, so these were the standard results which we had seen in the previous video. So now let us talk about the properties. So the first property of log is log of some base a plus log of n to the base a is equal to, most of you would be knowing this, m times n to the base a. So this is called as the first property, wherein the base on the left hand side should be equal to base on the right hand side. So if I have log of some number m to base a and log of some number n to base a, this is equal to log of m times n to the same base n. Okay, so no need to by heart all these things. I'll discuss the proof as well. Okay, so in maths, remember, when you study something with proof, you remember it for long. Okay, basically you don't have to remember this. Once you know the proof, easily you can derive it. Okay, so now what is the first thing? Let's assume that this guy m to the base a is equal to x, and basically I'm using LHS to prove it as RHS. Okay, and log of n to base a is equal to y. So using the property of log, how do I read this? What power of a is m, isn't it? So in exponential form, how I can convert? I can say m is equal to a to the power x, and from here I can say n is equal to a to the power of y. Okay, now let's talk about the RHS. What do I need in RHS? I need the product of m and n, isn't it? So therefore, these two, if I multiply m and n, which is 1 and 2, okay, so what will I get? I'll get a power x times a to the power y, isn't it so? Now from elementary classes, you guys know if bases are same, right, in multiplication, the power gets added, isn't it so? When the bases are same in multiplication, the power gets added. Therefore, I can say here that m times n is equal to a to the power x plus y, isn't it? Now you take log both the sides with the same base as a. Okay, here the base is a to the power x plus y. Okay, now taking log both sides to the same base a, I can therefore write a to the power x plus y, isn't it? So both sides I'm taking log to the base a, isn't it? Now see this right hand side, this part. Okay, so this entire thing using the definition of log in the exponential form. What will be the exponential form of this? What power of a will eventually give you a power x plus y, right? So it is like this, log 2 to the power 3 base 2. So what power of 2 will give you 2 power 3? Isn't it 3? So the answer over here is what? X plus y. So we got log of m times n to the base a as x plus y, isn't it? Now, what is x and y? X and y we have already assumed in the first case, the LHS part, that x is what? I can replace it back. Log of m to the base a plus y is log of n to the base a. And henceforth we have proved it, isn't it? This is what the proof is. So this is called as the sum product identity. Sum of two logs to the same base is equal to the product of it. Okay. I hope you like this proof and you have understood it. All right. Now let's move on to the next property, which is division basically. So let me write it down here. Second property. So the second property says log of m to the base a minus log of n to the base a is equal to log of m over n to the same base a. All right. Now, as I have discussed, let's consider the proof of this. So how do we deal with the proof? We'll follow the same approach. Take the LHS part and assume that log of m to base a is some value x and log of n to base a is some value y. And therefore, I can write this in exponential form as m is equal to a to the power x, and from here n is equal to a to the power y, right? Because what power of a is n? This is how I read. So when I convert this into exponential form, it will become n is equal to a to the power y, isn't it? Now what do I need from RHS? I need m over n, isn't it? Therefore m over n would be what? This is equation 1, this is equation 2. So a power x over a power y. Now from elementary classes, you guys know that if I have the same base, right, and in division, the power gets subtracted, isn't it? Using laws of indices, I can write like this. So therefore, m over n can be written as a to the power x minus y. Now take log a both sides. Log a of m over n. I can do that, right? To the same base, it will remain same. So this is for the fact that if 8 is equal to 8, then log of 8 to the base a will be same as log of 8 to the base a, isn't it? So I can write like this for any positive number. Okay, so this is what the concept is behind this. All right, so this becomes a to the power x minus y and to the base a. Okay, now, so what will be this answer? Log of a to the base a to the power x minus y. So I can rewrite this thing as x minus y, isn't it? Because a to what power is a power x minus y? It's x minus y itself. And henceforth we get this. Now put the value of x and y back, which we had assumed initially, that x is this and y is this. And therefore we get it as log of m to base a minus log of n to base a. Got it? So that's how we prove the second property. Okay, is this thing clear? Fine. Now moving on to the third property. So third property is also interesting. Okay, so let's understand that. Now the third property says if I have log of m to the power of n, all right, to the base a, then this n, right, the power n could be written in front like this. It comes out of log, and I can write m to the base a. Okay, it's in multiplication minded here, right? So it gets multiplied. So whatever is the power of the number, it gets in front to the same base. Okay, now let's see the proof of it. So how the proof goes, let's see here. So now let's assume that from RHS part, okay, this guy is equal to some x. Log of m to base a is some value x. Okay, let's assume that this is equal to x. Now, how do I write the exponential form of this? I can write a is equal to a to the power x, isn't it? Can we write like this? Perfect. Now, I need some power of n, right? M to the power n we have. So what I can do is taking power n both sides, whole thing to the power n is equal to ax, whole thing to the power n. Now, why I'm taking n? Because it's there in the property as well, right? Now I know from the laws of indices, elementary classes, that if I have x to the power 2 whole thing to the power 3, right? This becomes 2 times 3. Power to the power gets multiplied, right? So applying the same logic here, this becomes m power n is equal to a to the power xn. Yes or no? So this becomes a to the power xn. Now take log a both sides, because here also log a and log a is there. So let me take both sides. M power n is equal to log of a to the power xn to the base a. Correct? Now, what will happen to the right hand side? What power of a is a to the power xn? So since we know that 2 to the power 2 to the base 2 is nothing but 2, right? 2 power 2 is only 2 power 2, right? So this becomes xn. What power of base a is a to the power xn? So xn, isn't it? And I can write the LHS RS as it is. Now, what is the product of x and n? What was this x? Initially, we had assumed equation 1. Now, you put this over here, the value of x, what we had assumed earlier. So, n is already there. We get log m to the base a, and hence we have proved it. Okay, so let me discuss it once more. You assume the right hand side, log m to base a as some value x. Okay, and then you can write this in the exponential form as this. Now, taking both sides the power of n, I can do that because I'm doing it on both sides. Then eventually power to the power gets multiplied. So I can write like this. Now take log a both sides. And now using the property of log, I can say log of a power xn to the base a is xn. And now replace the value of x here. So we have proved it. Okay, perfect. Now moving on to the fourth property. So let's discuss what is the fourth property. So fourth property says if I have a log of some number n to the same base, right? So that's in power. So this is basically equal to n, right? A raised to log, a raised to this log n, this entire thing is in power. Okay. So log n to base a. So whenever this base and this base both are same, then the answer is simply n. Okay. Now the proof of this is also very elegant. So let's try to do that. Now all we have to do is just assume here that this log of n to the base a. Okay, this is equal to some x, and therefore can I say n is equal to, in the exponential form, a to the power x. Are you getting this? So now taking both sides, log a, base as log a, so we get this thing, right? So what do we get? We get log n to the base a is equal to basically x. What power of a is a power x? That is x itself, isn't it? So what we had proved from here is x is equal to this, isn't it? So we had proved this thing, and we have proved that x is equal to this again. Yes or no? Right. And what was x? X was this thing, right? Yes or no? X is basically equal to this. And therefore, what we can say, a to the power x is equal to n. And what is n? What's n? Okay, so I could actually write this. If you're not getting, try to visualize this. Okay, once I have this n, right? So what is n equal to? N is equal to this thing, isn't it? We got a power x is equal to n. Now what was x? X is again this thing, no? What I'm trying to say here is, what is x? This x. You put it back here. So this becomes a and this. Right? Since n is equal to a to the power x, and x is what? Log n to the base a itself. So I can rewrite it like this. Okay, I hope you are able to visualize now, if not in the previous case. So we have assumed this thing equal to x. Now n is a to the power x, and now replace again x value. So you'll get this. Okay. All right. Now moving on to the fifth one. Fifth one is a very interesting property that is based on base change formula. Base change theorem. What is this base change theorem? Let's try to understand this. So base change theorem basically says if I have, log of any number, let's say some positive number b to the base a, this can be written with a different basis. Okay, I can actually change this base and I can write it as log of b to some base c over log of a to the base c. So whatever is the base over here, a, now this can be written in the denominator with a different base c. Okay, and the number itself over here, b as it is with some different base c. All right, so we can do this. So this is basically called as base change theorem. Writing one logarithmic form into some other base like this. Okay, so let's try to see the proof of this. Let me use a different color. Let's understand what is the proof over here. So the proof goes like this. Start with LHS. You assume that log of b to the base a is equal to some number x. So in the exponential form, I can say here b is equal to a to the power x. Yes or no? B is equal to a to the power x in the exponential form. So that's 1. So log b to the base a equal to x, and therefore its exponential form will be b equal to a to the power x. Yes or no? Perfect. So now we got b is equal to a to the power x. Now, as we have seen earlier, the concept behind this concept says if two numbers, let's say 4 is equal to 4, then log of a 4, if I take log a both sides, then that will also be equal, isn't it? So now after this step, if I take log b, since b is equal to a to the power x, right? LHS is equal to RHS. So if I take log to some base c, purposely I'm taking this c a to the power x. So these two things will also be equal. Yes or no? They will be equal, isn't it? So now what I can say here is basically using the previous property. Okay. Now just concentrate on this. This is a power x, right? So we have seen since this property of log of m to the power n to the base a, which is n times log of m to the base a. We have seen this property just now, right? I think that was the third property. So which property I'm going to apply here? The third property, right? The power comes in front, right? So applying that property, so I can simply say x comes out log of a to the base c, and therefore it is equal to log b to the base c. Now I need to find x value, right? So therefore I can say log of b to the base c over log of a to the base c is equal to x. Now what was x? X was this equation, log b. So that's my x. So I put the value of x here, okay, which is equal to log b to the base a. And that is how we change the base. Simple, isn't it? Hence, we have proved this. Got it? So the proof of this base change formula is very, very important. And there are certain applications of it, which is again very important. So let me talk about that as well. The application of base change formula. So one of the major application is this property. Mark it as very important. If I have log of a to some base b multiplied by log of b to the base a. Okay, if I interchange the base and the number, and if I take the product of it, I'll basically get 1. Okay, so let's understand the proof of this one. So the proof goes this way. So using base change formula, you can take any base, right? So if you want to write to the base c, so you can write using base change formula log a to the base b. You could change the base c multiplied by log of b to the same base c over log of a to the same base c. Okay, so log a to the base c, this and this cancels out, this and this cancels out, you therefore get 1. All right, so this is one of the most important results of base change formula. Getting this? Perfect. Now let's talk about the sixth property. So the sixth property goes this way. If I have log of m to some base a, and this thing is to the power k. Okay, the power of a is k over here. Therefore, I can write this thing, all right, log of m to the base a, and this power k comes in front. Something sort of this. All right. So whenever we have log of some number to base and the base power is given, the power of base you could write in the denominator in front with the multiplication sign over here. Are you getting this thing? Okay. Now let's talk about the proof. Do try this, pause this video, and do check the proof of it. If you could prove it, well and good. Otherwise, look here. Now, can I apply base change formula here? Base change theorem on LHS. Try to think. Can I write log of m to the base a power k as to some base, let's say to the base a itself? Okay. Or yeah, to the base a itself. So I could write it as log of m to the base a over log of a to the power k to the base a, isn't it? So I've applied base change formula here, and therefore log of m to the base a power k can be written as log of m to base a over log of a to the power k to the base a. Now, just now we have seen that this remains as it is, log of m to the base a, that whenever we have a to the some power, right? So this will become k will come outside of it, and this becomes log of a to the base a. Now, what is log of a to the base a? Isn't it equal to 1? So what do we get? 1 over k times log of m to the base a. And hence we have proved it, right? I hope you got this result as well. Okay, so using base change formula with the same base, I could do this. All right. Now, the last one, the seventh property, which is again also very interesting. So it says if I have a log of c to the base b, right? So then this is equal to, you just change this number with the base itself. So c log of base b a. Okay, so in the power, whatever is the base, log c to the base b. So here it will become log a to the base b. So you just interchange this ac, it will become ca. Okay, so what we can do over here is, let's check the proof of this. And the proof goes like this. Let's see the LHS part. Now, I'm applying base change theorem on the power itself. So I have a, and writing using base change theorem, I'm writing here in short form BCT, stands for base change theorem. So I can write log c to the base b with a common base as a. So that will become log c to the base a over log b to the base a. Okay, this is a raised to this power. I hope you are getting it. Let me put it once more correctly. Something sort of this. Okay, so this is what we have. Yes or no? So now, see here. We have seen in the elementary classes, if a to the power m is equal to 1 over n, this is same as writing a to the power m over n, which can be rewritten as a to the power 1 over n whole thing to the power n, isn't it? So I can switch these two places, right? So applying the same logic over here, since I can say this can be written as a, all right? So I could actually write this thing as log of, let this c to the base a be as it is, whole thing to the power 1 over log b to the base a, isn't it? Now, from the previous property, we have seen that from the sixth property or the fifth property, basically, no, the fourth property, log of, you know, e raised to log of n to base a. Whenever this base and this base are equal, the answer is the number itself. So using this property, the fourth property, I can say this result will be equal to what? C. Okay. C raised to what power? 1 over log of b raised to a, isn't it? And then this 1 over log b to the base a can be written with this result, which we have just now proved from here, since log of a to the base b can be written as 1 over log of b to the base a. When we interchange, it becomes the reciprocal of each other, right? So what will be the reciprocal of this power? Reciprocal would be log of a to the base b, isn't it? So hence we have proved it. What was the LHS part? LHS was this a log c to the base b. Got it? Perfect. So I hope you understood all the proofs of these important properties of logarithms. Stay tuned for the questions based on all these properties. Okay. Pause this video, do try on your own, right? There are so many ways to prove it. Okay. So it's not necessary and hard and fast rule in mathematics that there is only one rule to prove something. Okay. So do give it a try. Try to figure out your own, way of proving it. So I hope you enjoyed the session. Thanks for watching. Bye bye. Take care.